In section 1.3, we get our first definition of the trigonometric functions. So this is the first of three definitions. Let's go ahead and take a look. It says if theta is an angle in standard position and the point xy is any point on the terminal side of theta other than the origin, then the six trigonometric functions of theta are defined as follow. So here are the six trig functions. We have the sine, the cosine, tangent, cotangent, secant, and cosecant of our angle theta. And each one of those functions gets a three-letter abbreviation. And all of the abbreviations are really straightforward except for cosine and cosecant. They both begin with COS. So COS stands for cosine, and for cosecant we use CSC, as I've highlighted there. So the definition states that the sine of the angle theta is y divided by r. Now, what is r? Well, if we go to our diagram, here's an example of an angle theta drawn in standard position. The point xy is some point on the terminal side of theta. And notice that you can draw a triangle here where this side is x and this side is y. And then r is defined to be the distance from the origin to the point xy. So because r is nothing more than the hypotenuse of a triangle, and we know from the Pythagorean theorem that x squared plus y squared must be equal to r squared, by taking the square root of both sides, we get r is equal to the square root of x squared plus y squared. So r is nothing more than the distance from the origin to the point xy, and we can find it once we know the value of x and y. So basically, all you need to know is the point on the terminal side of theta, and then you can determine r, and then you have your six definitions here. So sine of theta is y divided by r, cosine of theta is x divided by r, tangent of theta is y divided by x, and so on. Now, I want you to notice something about this definition. I want you to notice that the sine of theta and the cosecant of theta are reciprocals of each other. See, one is y divided by r and the other is r divided by y. The same thing is true for cosine of theta and secant of theta. Those are reciprocals. And also tangent of theta and cotangent of theta are reciprocals. Now that's really nice because what that means is that if you know sine, cosine, and tangent, and if you know which one of these trig functions is the reciprocal of those functions, then you only have to memorize three of these, and then the other three you can get by simply knowing the reciprocal relationships. Let's do an example. So in this first example, it says to find the six trigonometric functions for theta if theta is in standard position and the point -2, 3 is on the terminal side of theta. So what you'll need to do this problem is first of all, just graph the point -2, 3. So if I have a coordinate system, x equals -2, y equals +3 is this point right here. And that point is on the terminal side of theta. So if I draw my angle in standard position, the terminal side is going to look something like this. And of course, this is the initial side here. And so this is what theta looks like. Now, just to be clear, you don't have to draw the angle theta in order to get the six trigonometric functions. But I like to draw theta just because I think it's important to associate a picture with everything that we're doing. Now, what I'm going to do is actually bring in a picture from the textbook that will look a little bit nicer. So here is that angle theta in standard position. We have the point -2,3 on the terminal side of theta. Now to get the 6 trigonometric functions, we need to know the value of r. Now this is the computation for r, but just to show you, remember that r is equal to the square root of x squared plus y squared. And in this case, that's the square root of x. X is -2. So it's going to be -2 squared, and then plus y squared, which is 3, right? Because y is 3. And that is the square root of +4 plus +9, which is the square root of 13. So that is where this computation comes from. So now, once I have x, y, and r, again, x is -2, y is 3, and r is the square root of 13. From there, I can just get the 6 trigonometric functions by memorizing them. It is important that you memorize these. So again, the sine of theta is equal to y divided by r. Y is 3, r is radical 13, and we'll leave our answer just like that. Cosine of theta is x divided by r. X is -2. R is, again, the square root of 13. And the tangent of theta is y divided by x. And y is 3, and x is -2. And the only thing I would do here is I would rewrite this as -3/2. Now, once I have those, I can get the rest by knowing the reciprocal relations. So the reciprocal of sine is cosecant. Cosecant of theta is r divided by y. So all I have to do to get cosecant is just take the reciprocal of this fraction. So that's going to be the square root of 13 over 3. Reciprocal of cosine is secant. The secant of theta is r divided by x. And again, all I need to do here is take the reciprocal of this fraction. Now, when I take the reciprocal, I'm going to keep the negative in the numerator. So we'll rewrite that as negative radical 13 over 2. And then cotangent of theta is the reciprocal of tangent. So it's x divided by y, and that's going to be -2/3. So those are our 6 trigonometric functions of theta. Now, one note that I want to make here is in algebra, and I mentioned this in an earlier video, but in algebra, you are taught to not have a radical in the denominator of a fraction. In this class, we're not going to worry too much about that. So let me post this little note from the book here. So the note from the book says, in algebra, when we encounter expressions like 3 over radical 13 that contain a radical in the denominator, we usually rationalize the denominator. And that process involves multiplying the numerator and the denominator by radical 13, in which case we end up getting the fraction 3 radical 13 over 13. But this is actually sometimes a more complicated expression than just leaving it as 3 over radical 13. So both of these are correct, but much of the time when we have an answer like this, we're just going to prefer to leave it in this format versus rationalizing the denominator, okay? So again, from time to time we will rationalize, but most of the time we won't. So that's just a note moving forward. In our second example, we want to find the sine, cosine, and tangent of 30 degrees. So this time I'm giving you the degree measure of the angle, but I did not give you the point on the terminal side of the angle. So we need to figure that out first. So the first thing I'm going to do is graph my angle in standard position. So 30 degrees looks something like this. And then I need to pick any point on the terminal side of theta. So I need to figure out, what is the x value here and what is the y value. And there's no unique answer for this because we could have chosen this point to be anywhere on the terminal side. So what I'm going to do here is draw a perpendicular line segment here to make a right triangle. And then I want you to notice that what you have now is a 30, 60, 90 triangle, right? This angle up here is 60 degrees. In a 30, 60, 90 triangle, once we know what the short leg is equal to, we can easily figure out what everything else is equal to. So I can choose any value that I want for this length. So for simplicity, I'm going to choose this value to be equal to 1. And that's our y value. Now, if I choose that to be 1, remember this leg of the right triangle is the longer leg. And the longer leg is calculated by taking the short leg and multiplying it by radical 3. So the longer leg here, which is x, is going to be 1 times radical 3, which of course is just radical 3. And then now to figure out the hypotenuse, we can actually do this two ways. The easiest way to do it, in this case, is just to remember that in a 30, 60, 90 triangle, the hypotenuse is twice as big as the short leg. So if the short leg is 1, the hypotenuse is 2. Now, we could also have figured this out by using the formula for r, right? So we can do this, square root of radical 3 squared plus 1 squared. And this would be the square root of 3 plus 1, which is the square root of 4, which is 2. Now, once we know these values, we can easily find the sine of 30 degrees, the cosine of 30 degrees, and the tangent of 30 degrees. We just need to remember our definitions. So sine is y divided by r, y is 1, r is 2, so that's going to be 1/2. Cosine is x divided by r, x is radical 3, r is 2, and so that's radical 3 over 2. And tangent is y divided by x, which is 1 divided by radical 3, and we'll go ahead and leave it like that. So you're either going to be given the point on the terminal side of theta, or you will be able to figure it out by drawing some kind of a special triangle. In the next example, we look at an example of finding the 6 trig functions of a quadrantal angle. So in this case, we have 180 degrees. So again, to find the 6 trig functions, the first thing I need to do is graph that angle in standard position. So let's see, we're going to start here and we're going to rotate 180 degrees, which is going to bring us over to here. So here is the terminal side. And now what I need to do is I need to pick any point on the terminal side of theta. Now, I can pick any x value over here, but it is true that x has to be negative because we are to the left of the origin. So my favorite x value that is negative is x equals -1. And of course, the y value has to be 0 because we are on the x-axis. And on the x-axis, y is 0. Now r is the distance from the origin to this point. Well, this distance is 1 unit because I chose x to be -1. So r is equal to 1. Now again, you can find r by using the formula. So the point here is I can use the formula to find r, or a lot of times we can figure out r more easily by simply looking at the picture. So at any rate, we have x equals -1, y equals 0, and r equals 1. And so now we can find the sine of 180 degrees, the cosine of 180, the tangent of 180, and then we will find the cosecant of 180, the secant of 180, and the cotangent of 180. So let's go ahead and go through and do this. So remember, sine is equal to y divided by r. y is 0, r is 1, 0 divided by 1 is 0. Cosine of 180 degrees is x divided by r. X in this case is negative 1. R is positive 1. Negative 1 divided by 1 is negative 1. Tangent is y divided by x, which in this case is 0 divided by negative 1, which is 0. And then for cosecant, cosecant is r divided by y. R is 1, y is 0. Now you need to remember, you cannot divide by 0. So anytime we divide by 0, we have to say that this is undefined. Secant of 180, secant would be r divided by x, which in this case is 1 divided by negative 1, which is negative 1. And cotangent of 180 is x divided by y, which is negative 1 divided by 0, which is once again undefined. So these are the 6 trigonometric functions of the angle 180 degrees. So I want you to notice that anytime you divide by 0, your trig function is going to be undefined. And so tangent, cotangent, secant, and cosecant will sometimes be undefined because depending on the angle, x or y could be equal to 0. However, sine and cosine will never be undefined because r is never 0, right? R is always the distance from the origin to the point on the terminal side, and so that distance cannot be 0. So sine and cosine are always defined. All right, so in this next problem, we are given the value of sine of theta. So we are told that sine of theta is equal to 12 divided by 13. And we are also told that theta terminates in quadrant 2. And what they want us to do is find the remaining trig functions. So what I'm going to do is sketch a diagram. Since theta terminates in quadrant 2, I will just draw some random angle terminating in quadrant 2. So there's theta. I'm going to pick a point on the terminal side, and I like to draw this little reference triangle here. This is x, this is y, and this is r. And let's keep in mind that we know that sine of theta is 12 divided by 13, but we also know that sine of theta is y divided by r. Okay, so this strongly suggests that y is 12 and r is 13. And that certainly could be the case. But it doesn't necessarily mean that y and r are these values. What it means is that when you divide y by r, you get the same thing as 12 divided by 13. So although it is true that we could choose y to be 12 and r to be 13, we could just have easily have chosen y to be 24 and r to be 26, because 24 divided by 26 is the same as 12 divided by 13. So when you're given a trig function, don't automatically assume that this is the value of y and this is the value of r. Oftentimes, that is the easiest choice, but sometimes you have to be a little bit careful with that. Okay, now we will go ahead and just choose y to be 12 and r to be 13. In that case, we need to know what x is. So let's remember that x squared plus y squared is equal to r squared. So that means that x squared plus y, which is 12 squared, is equal to r, which is 13 squared. So that's x squared plus 144 is equal to 169. Subtracting 144 from both sides, we get x squared is equal to 25. And now if I take the square root of both sides, remember, this is the absolute value of x is equal to 5, which means that x can either be positive or negative 5. But x can't actually be positive or negative 5. It has to be one or the other. So let's remember that if theta terminates in quadrant 2, that means we're over here in the second quadrant. And in the second quadrant, x is negative. So the value of x for us must be x equals negative 5. Now once I have x equals negative 5, y equals 12, and r equals 13, we can then very easily find the trig functions using the definition. And I'll go ahead and put those down here. And so plugging in the values for x, y, and r into our definitions, we can get the 6 trigonometric functions of theta given the information that we had. Let's try another one. So here we have the same situation. We're given tangent of theta is negative 4/3, and theta terminates in quadrant 4. Let's draw a picture of this. So first thing I'm going to do is sketch an angle terminating in quadrant 4, and you don't have to be precise with how you draw this angle. We just want to make sure that it definitely does terminate in quadrant 4. Then I'm going to pick any point on the terminal side, and from there I'm going to draw a line perpendicular to the x-axis, making a triangle. And in this triangle, this is x, this is y, and this is r. And we know that tangent of theta is y divided by x, and in this case, they told us tangent is negative 4/3. Now, I want you to think carefully about that, because negative 4/3 could be negative 4 divided by 3, or it could be positive 4 divided by negative 3, you see. So one way to think about this is y would be negative 4 and x would be 3, or y could be positive 4 and x could be negative 3. And again, these aren't our only two choices, right? I mean, I could have picked anything that gives us the same ratio. So for example, I could have chosen y equals negative 8 and x equals positive 6. But anyway, I'm going to go with the easier choices. So it's one of these two, let's say. Well, in the fourth quadrant, y is negative and x is positive. So it can't be this choice here. So we can eliminate this as a possibility. So if I'm going to go with something, it's going to be this one here. Now, once I have chosen those values for x and y, r can be found by taking the square root of x squared plus y squared, which is the square root of 3 squared plus negative 4 squared, which is the square root of 9 plus 16, or the square root of 25, which is 5. So x is 3, y is negative 4, and r is 5. And from here, we can go ahead and get our 6 trigonometric ratios. And here they are for your reference. Now, I left out the definition. That's because we should start to get used to the fact that, for example, sine of theta is y divided by r, y is negative 4, and r is 5. So I'm simply plugging those values in, and the same thing for the rest. All right, so this concludes 1.3. Actually, that's not the end of section 1.3. I have one more thing to talk about here, and that is the signs of your trig functions. So when an angle theta is in the first quadrant, all 6 of the trig functions are going to be positive. And that's because in the first quadrant, everything's positive. X is positive, y is positive, r is positive. So no matter which two variables you divide, you are always going to get a positive number. In the second quadrant, it's not true that they're all positive. In the second quadrant, cosine and secant will be negative, and tangent and cotangent will be negative. Let's talk about why that's the case. So let's think about an angle in the second quadrant, which looks something like this. There's your angle theta. If you pick a point on the terminal side of theta, and that point is xy, we know in the second quadrant, x is negative and y is positive, right? So notice I say x is less than 0. That just means negative. and y is greater than 0, that means positive. And of course, r is always positive. So if you say cosine of theta is x divided by r, x is negative. So you are taking a negative number and you're dividing it by r, and r is positive, so that's a positive number. And a negative divided by a positive is a negative. Same thing for secant, because secant is just the reciprocal of that number. And then if you take something like tangent of theta, tangent is y divided by x. Well, y is a positive number, but x is a negative number, and a positive divided by a negative is a negative. So I'm explaining why in quadrant 2, cosine and secant, tangent and cotangent are all negative values in the second quadrant. It has to do with whether x, y, and r are positive or negative. Now you can go through and do this for every single quadrant, but the way to remember this is not where the trig functions are negative, but rather where they are positive. So I want you to notice that in the first quadrant, they are all positive. In the second quadrant, only sine and its reciprocal, which is cosecant, is positive. In the third quadrant, only tangent and its reciprocal, cotangent, is positive. And finally, in the fourth quadrant, only cosine and secant are positive. So there's kind of an easy way to remember where the trig functions are positive or negative. So we have our 4 quadrants. Quadrants 1, 2, 3, and 4. In the first quadrant, they are all positive. So we put an A to represent all. In the second quadrant, only sine and cosecant are positive. So we put an S, and that represents sine and its reciprocal, cosecant. In the third quadrant, tangent is positive and its reciprocal, cotangent. And in the fourth quadrant, cosine is positive and its reciprocal, which is secant. So the ASTC, the acronym there, stands for all sine and cosine, tangent and cotangent. It stands for all sine and cosecant, tangent and cotangent, and cosine and secant. And a kind of an easy way to remember this is to come up with your own acronym. And so a lot of times what we like to say as teachers, as math teachers, we'll say all students take calculus. So that kind of emphasizes the ASTC, and it gives us sort of a way to memorize in which quadrants are which functions, positive or negative. All right. This will come up later on in the course, and so I want to make sure that I mention it here. Okay, now we're done.